ellipses. You guys did yesterday the same thing we're going to do today, but now we're going to have, instead of being at the origin, we're going to have an h and a k. H's go with x's, k's go with y, just like they did with parabolas. Your a, God bless you. Your a value is still going to be the distance from the center to a vertex. Your b value is still going to be, and I'll put the formula up so you can see it. Your b value is still going to be distance from, God bless you, center to co-vertex. And c is still going to be, anybody else? This is a blanket to bless you for the rest of the class. So now, at this point, what's going to happen here is all the same rules from yesterday still apply. Whenever number is bigger in the denominator, that becomes your a squared. The c squared is still found the same way. C squared is still going to be a squared minus the b squared. That doesn't change. So basically what we're looking at today is one extra step from what you did yesterday. It's figuring out where h and k is to start the problem. Plotting and working through the ordered pairs is also extraordinarily straightforward. There will be 3 basic examples of the types of problems we're going to work on today, and I'll give you some stuff to do for tonight. Tomorrow, we'll do the presentations of any of the stuff that you guys have. If you can, please try to email it to me before class. That way I can get it on the computer and up and ready to roll. Yes, ma'am. That's fine. Okay. Then tomorrow, after that's done, I need about 6 minutes to remind you guys how to graph a circle. And then I'll give you a couple of those to do, and that we won't do hyperbolas tomorrow because there's no point to do it over the weekend because you're not going to do it anymore. You'll have some work to do, and I mean, I'm not going to give you a ton. It's just I want you. I know if I give you hyperbola, you're not going to do it. So I'm not going to. Why fight the battle? There's no point in it. So let's talk about this. Points in hyperbolas. It's kind of funny because there are. In this case, here's what we've got. We've got quantity x minus 3 squared over 25 plus quantity y plus 6 squared over 49 equals 1. Right off the bat, you could probably tell me what direction this is being stretched. Being stretched vertically. So what should we do? Draw a little vertical looking ellipse. That way you don't screw up when you go to graph. The reason we know that it's stretched up and down is because the 49 is bigger than 25. I hope. Okay. From there, could you now tell me where my center is? Center is at 3 and negative 6. H and K. What is a squared?
27 and 49.
A squared is 49. A is
7.
Plus or minus 7.
oh. B is
Plus or minus 5.
okay. Sorry. B squared is 25. Thank you. B is 20. I got ahead of myself there. And then lastly, you okay? Take a deep breath.
It's student council.
Yeah. It's homecoming.
C squared is still going to be 49 minus 25. You get 24 for C squared.
Plus or minus.
I just said C squared was 24. It'll be plus or minus 2 root 6. Okay? Okay. At this point, you've given me all the information that you need to do, aside from plotting and ordered pairs. You're going to find out that this is extremely easy to do. So you start with your center. Three, negative 6. I know that this is going to open up and down. So So when I go to walk to my vertice, do I walk up or do I walk to the left and right?
You walk out.
I walk up. How much do I walk up for my vertex? 7. So -6 plus 7 is?
1.
So that one is at 3, 1. -6 minus 7 is? Very good. Here's what I'd like you to get in the habit of doing. When you have shifted ellipses, or next week we talk about hyperbola, start making a list of your values right away. Vertex is located at 3, 1, and then 3, -13. Okay? Yes, sir?
Would it matter if we said square root of 24 instead of 2 square root of 6?
Always simplify roots.
Okay.
Okay? Always simplify roots.
Is this the directrix and
No, that's for hyperbolas. Ellipses don't have that. Ellipses have the vertex and co-vertex. Okay? Oh, and focus. Now, B value, we have to move left and right from our vertex to our co-vertex. So when I go left and right, from the center, yeah. Did I say something wrong?
Yes.
Thank you. When I go from my center, left and right, 5, well, what's 3 plus 5? And 8 -6. And what's 3 minus 5? So my co-vertices are at -2, -6, 8, -6. You okay with that? What's left to plot? The foci, the C value. Now, this is where I kind of go back and forth to approximations for plotting. We know that the C value is 2√6, otherwise known as the square root of 24. The square root of 24 is a smidge less than the square root of 25, right? What's the square root of 25? What's a smidge less than that? 4-ish? So if I move up 4-ish, so let's see, 1, 2, 3, 4-ish, and down 4-ish, we call it a day. Okay, here's how you label that. Does everybody agree that I went from my center and I added 2√6? To what part of the center did I add 2√6? The x or the y coordinate? The y coordinate. Here's how I write this. This is going to be new to you. My focus, the x value doesn't change. It's at 3, comma. Well, what was the y value to start at the center? -6. To the -6, I added 2√6, and then 3, comma -6, I have to subtract 2√6. And that's how you write that as an exact answer. It looks like crap, but that's what it means. It's weird.
Why?
Why? Well, because I added two y values.
What is?
Sorry. All we did here, guys, is I just added, I took the C value, that's the distance from the center to the focus. I can't combine that at all, so I just leave it like that. Yeah, Bo.
What does the focus help you do in the problems?
In an ellipse, well, I didn't tell that nicely at all. In an ellipse, remember your vertex is always looking at the focus. Depending upon where the focus is placed, it allows you to see how fat or how skinny the ellipse is. Just like we did the other day with the ellipse, with the parabola. If the closer the focus was to the parabola, the wider the parabola got, the farther away it went. That's all it means. That's all it does. And remember, the focus is the point at which all points on the ellipse, the sum of them are equidistant to the two values. All right. Now, if we wanted to get really fancy, which we won't, we could find what's called the lattice rectum.
That's fun.
It's funny because it's about a butt.
It's funny because yesterday Miss Schultz said, "I will anally police you."
No, there are a lot of really weird math terms. There is something called a lattice rectum. We're not going to worry about it.
I want to know what it is.
Darn near killed.
There it is.
Can we find
Darn good. Yeah, that's perfect. That's how you graph these guys. It's extremely straightforward. All right. The only weird part is a lot of times that focus value's got a weird root to it. You just have to tack on like a plus root sign. Okay. Which means the second thing we're going to show you today is how do you write the equation. Great question. Kato's asking, what happens if your vertex or your co-vertex has root in it? Do you do the same thing? Yes. Okay. So now we're going to do something a little bit different. We're going to write the equation given ordered pairs. We know that this is an ellipse because it tells us it's an ellipse. We have foci at 3, 5, and 3, -1, and vertices at 3, 6, and 3, -2. So once again, the very first thing I'm going to do is sketch an idea of what in the world does this look like. So I'm going to plot some points. My foci are at 3, 5. And 3, -1. My vertices are then at 3, 6. And 3, -2. Is this vertical or horizontal? It's vertical. Now, Colton, this goes along with what you were talking about earlier. See how the focus is rather close to the vertex? This is going to be real. This is going to be a little bit a little bit fatter than the other ones.
All right.
Oh wait, no, I'm sorry. Skinnier, yes, because it's
The absolute value is closer. to
Yes.
the skinny- Yeah, I'm.
okay. So now, what happens here is we need to figure out where the and the center. Now, think about what we're talking about centers and distances. Your center is the halfway point between your vertices. Your center is the halfway point between your focus. Is your center also the halfway point between the co-vertex?
Yes.
So it's the midpoint of all that junk, right? So what's the x-coordinate going to be of the center?
Midpoint formula.
3.
3. I know that the HK for this, the H value has to be at 3 because it's going to be on that same vertical line. It's going to be on the same line as the vertex and the foci. So here comes a really tough question. What is 5 plus -1?
7.
What's half of that?
2.
There's your center. What we did there, guys, is we just walked through how to find the center. The center is going to be always located halfway between. Always. Yeah.
Can you like go back 30 seconds and like say that part again? Because like I missed it. Like,
Okay.
Let's get the voice
like how you got
recording
to
line.
2 and
Yeah. Okay.
Wait, halfway between what? The vertices?
Your center is always located halfway between vertices. It's always halfway between the focus. It's always going to be halfway between the co-vertices. It's the midpoint of all of those values. It will always be the midpoint of those values. Knowing in this case that it is a vertically shifted, or I don't want to say vertically skinny ellipse, that means that I know that the x-coordinate is going to be the same. Do you agree with that?
yeah.
Okay. So all I have to do is find the average of the y values. So what I did here is I just picked on the focus. I took 5 plus -1, got 4. What's happening? 2. If I did it with the vertices, I take 6 plus -2, I get 4. What's happening? 2. Yes, sir. It's the average. I'm just averaging the values. Yep. That's basically what I'm doing is the average. If you want to do the whole on thing of the midpoint, you're taking your x2 plus x1. Oh, sorry. x1 plus x2 over 2, comma y1, that whole thing. It's just, if we remember that we're vertical, the x value doesn't change. If we're horizontal, the y value doesn't change. It's just an easy way of
What is the midpoint formula?
So, yes, sir.
So will we then just like subtract the 506 and is the coordinate 1?
I don't know, I haven't gotten that far yet. I know that the distance from the center to the vertex is which value, A, B, or C? Center to vertex. So if I'm going from center to vertex, how far was that?
That was
4. I started at 2, I go up to 6, so my A value is 4. If I do the same thing to get to the C value, how far is that? So if A is 4, C is 3, what's the formula for A squared? So I get C squared is A squared minus B squared. 3 squared is 4 squared minus something squared. What's 3 squared? What's 4 squared? 16 minus what is 9? 7. Do you know what your A squared term is?
49.
Do you know what your A squared term is?
Yes.
What is it?
49.
What's your B squared? This is stretched left and right, so this is going to be an x minus h quantity squared, y minus k quantity squared equals 1. Where does a squared go under if it's stretched up and down? The x or the y? Where does a go? On the y. So a squared is under here. B squared is here. Fill in the blanks. X minus 3 quantity squared over 7 plus y minus 2 quantity squared over 16 equals 1. You don't have to graph the whole thing in order to do this. All you need to do is get the rough sketch, because more often than not, you're just walking your A's and your B's or your C values. Okay, and you fall back into that A squared minus B squared is going to get you your C squared. Okay, Colton, you okay?
I just don't get what B was and how we found it.
Okay. Did you see how we got A squared or how we got A?
Yeah.
A, remember, A is your distance from center to vertex. So A is 4. Center to focus is C, and it's 3. The formula is C squared is A squared minus B squared. 16 is A squared. 9 is C squared. 9 equals 16 minus what?
7, which I have, so B equals.
No, B, I don't care what B is. All I need is B squared, my friend.
Oh.
Remember, we're not plotting it out. We don't need to actually mark off root 7 on our diagram in order to figure out what B squared is. And this is where a lot of students kind of get hung up, like, well, I got to figure out what B is. You really don't.
Okay.
You know, it's one of those types that just as long as you identify it, you're good to go. You don't need to do anything else.
Okay.
Okay? Yes, sir.
What happens when they have vertexes, and then you have they give you the co-vertexes, and they give you the foci. Can you find the vertexes outside?
Yes. Oh, that's going to be a hyperbola. If the focus is outside on the other side, it's a hyperbola.
So I mean, like they give you you can see the outline, but you need to find the vertexes on the outside of the foci. Can you find that?
If you have co-vertices, yes.
Okay.
You do the exact same setup. You'll have B squared and C squared find A squared.
Okay.
So it'll be something like 25 equals something minus 9.
Okay.
That's all it is. Okay, that's all it is. All right. Not so scary, is it?
Well, you saying this.
I'm
Saying like that. You never ever say that.
They're not. Guys, this is another scenario just like you guys did with your, I know. It's the same thing as the parabola, but now instead of having to complete the square once, you have to do it. That's it.
Yeah.
Okay. Now, let me explain to you what they're giving you here. This is what they call the quadratic form of a conic. All right. It's very weird. It's very interesting how they do this. There are ways to identify what type of a conic something is going to be by using a bunch of different formulas, I find that to be a big, bless you, I find that to be a big giant waste of time. The reason is, no matter what, you still have to write the equation out. So if you follow these simple steps, you're always going to fall into the same place to figure out what you have. So just like we did with completing the square stuff with parabolas, what did we do? Remember we got all the squared terms together, the variables together that were the same, we moved the constant stuff over. We're going to do the same thing. We're going to try and figure out, is it going to be, we want to get it, is it x minus h quantity squared or y minus k quantity squared? Which means we're going to kick the 36 out. Move it to the other side. Are we okay with that? Just the constant I'm talking about. Move the constant. So I'm going to regroup this. 9x squared plus 36x plus 4y squared minus 24y equals negative 36.
So, do we move the y's to the other side first?
No, because if you look at the generic formula for the ellipse, you have the x squareds and the y squareds both on the same side. Right? Everyone okay with this? All right. Now, when we go to complete the square, what does your first term always have to be? It has to be 1. So I got to factor out the leading term coefficients of both the x squared and the y squared. And here's how this looks. I take the 9 out of here. I have x squared plus 4x. And remember when we did complete the square, I always put that blank.
Yeah.
So I remember that I have to add something in.
Yep.
I'm going to put that in. Close my parenthesis. I can do the exact same thing with the y squareds. Y squared minus 6y blank equals negative 36. Now, here's what you have to remember to do. I factored out a 9 on this side. What should I make sure I put on this side?
A 9.
A 9. Because what's going to happen is when we take half of 4 and square it, we're going to add it into here and over here. But if I add just that, I'm not multiplying it by the 9. What you have to do is whatever you factor out of this term, remember to put a 9 parentheses plus 4 parentheses. Whatever it may be. Sometimes this might be a positive value, sometimes it might be a negative value. Okay? Here's what's happening, Colton. You know how to complete the square, right?
Yeah.
All right, so walk me through this one. If I take half of 4, what is it?
Half of 4 is 2.
All right, square it, what do you get?
4.
Okay, so that equals 4, so I have to put 4 here. Do you agree?
Yeah.
Now, if I didn't have that 9 value here and I just added 4 to the other side, I'm missing out on a lot of other stuff.
Okay.
Because I factored out a 9, so it's supposed to be 9 times that.
Okay.
That's why I put it there. Does that make sense now?
Now it
So
makes
then does
sense.
4 go in the parentheses by the 9?
Correct.
Okay.
Okay?
That's what I.
So the 4 goes there. Sometimes you got to factor something out, sometimes you don't.
Do we not have to worry about 9 and 4 on the left side of it?
You do have to worry about it, and I'll show you why. In this case here, what was your term then that goes in parentheses? Is it 2 or negative 2? 2, because that was half of b. So this becomes x plus 2 quantity squared, but I got to bring the 9 there.
That's the second one is 9.
Correct. When I get to this part, I do the same thing. Half of negative 6 is negative 3. Squaring it, I get adding in a 9. Now, this is just dumb luck that the numbers are 4s and 9s. Because a lot of these things, they're trying to work as cleanly as possible with you guys. That's kind of why you're getting these. My parentheses term for the y squared, it's going to be y minus 3 quantity squared. But I have to put the 4 in front of it. All right. What's 9 times 4?
36.
What's 4 times 9?
36.
What's negative 36 plus 36?
0.
What's 0 plus 36?
36.
Good job.
That was difficult.
This is back to where you were talking about earlier. What happens when it doesn't equal 1?
Then we have to divide.
You divide everything by.
Full circle.
It's not a circle, it's an ellipse. Boom. It's total ellipse of the heart. Turn around.
Please stop. Please stop.
All right, what is this fraction? 1/4, good. So this becomes x plus 2 quantity squared over 4 plus y minus 3 quantity squared over equals, what direction is this being stretched? Vertical. Stretched up and down because 9 is bigger than 4.
You have to graph this.
Oh yeah, I'll have you graph this then. I mean, from there, graphing is a piece of cake, because what's your h and k? -2, +3. What's your a squared term?
9.
So what's a? What's your b squared? What's your b? Very easy to work from there, isn't it? This style problem is the one that takes the longest, because you got to complete the square to get to the point where you can factor out. The ones I'm giving you tonight should work very clean. Okay, but I'm not going to lie that sometimes when you're trying to find an h and a k off of a set of ordered pairs, you might get a fractional one, like a half z or something. It shouldn't be so bad because you're not really having to graph anything, you're just trying to write the equation. I do know that I did assign a problem in the other 2 classes that I completely forgot that gives you this god-awful answer. So I'm not going to give you that problem.
Mr. Murphy likes us.
Well, I wouldn't go that far, but we'll just say tolerate. Try these, guys. Like I said, you're gonna find that they are really straightforward. When you work with the ellipses, again, it's nothing more than knowing your formula. If you know the formula is the same thing as yesterday, you just packed in h and k. Everything else works the same, guys. Everything else works the same. You got about 10, 12 minutes you can get through. I bet you get through a couple. I'll be back in 1 second, right? Questions on that? Yep. Just like what's the formula? Y minus y sequence, you always change your sign. It's the same.
Or you used to say combine.
Mr. Murphy, Katie is bullying me.
80. What are you screwing up? Oh, I should probably turn this off.
No.